Hi everyone, this is CrossLangFuzzer, a testing tool for JVM cross-language interoperation. The JVM ecosystem is multilingual. Kotlin, Java, Scala, and Groovy all share the same bytecode, but each has its own type system, notability, and variance rules. When code crosses language boundaries, subtle inconsistencies appear. Compilers accept what they should reject, or vice versa. Existing fuzzers test one language in isolation. CrossLangFuzzer is the first differential testing tool built for JVM cross-language interoperation. It generates programs with Kotlin, Java, and Scala side by side, compiles them with multiple compilers, and flags disagreements. This picture shows a bug found by CrossLangFuzzer. Here we have a Java interface A method full, a parameter which type is list T. A Java class B implements A and overrides full with row type. A class C extend B will also implementing A. Everything's fine so far in Java, but when a Kotlin class X extends C, the Kotlin compiler rejects it, complaining that X hasn't overridden full. Interestingly, if you write X in Java, there's no problem. The issue comes from Kotlin not supporting row types. It thinks B didn't actually override its full, so this bug arises from different treatments of row types in Java and Kotlin. Here's how it works. The pipeline has 5 stages: generation, program generator builds an immediate reputation and IR that's valid by construction. It respects JVM inheritance rules, correctly resolves override candidates, and doesn't need post-hoc validation. Mutation. 6 mutators transform the AR, changing generic arguments, swapping notability, removing override stubs. These mutations are applied blindly. The resulting program may be semantically invalid, and that's intentional. Invalid programs can also trigger real compiler bugs. Print and compile. The AR printer emits source files in the target languages, Kotlin, Java, Scala. Each file is fed to its corresponding compiler. Differential and normal testing. If the compilers disagree on the same cross-language program, one accepts and another rejects, that's a candidate bug. If the compiler rejects a valid program, that's also a candidate bug. Reduction. The minimizer shrinks the failing program by removing AR elements one at a time. The result is a minimal human-readable cross-language test case. The figure shows the workflow of the automated reduction. If no more trails in the current program, we can see the program is ready to be reported. Before lab demo, here's the code design, a language-agnostic IR. Traditional fuzzers generate source code directly. We take a different approach. One IR tree feeds a Kotlin print, a Java print, and a Scala printer. When a bug is found, the IR is identical. Only the language-specific rendering differs. The IR represents classes, interfaces, generics, inheritance, and notability, all the building blocks of JVM programs, and is built valid by construction with no post-hoc validation needed. Now let's say it's wrong. The easiest way to try CrossLangFuzzer is through the pre-built Docker image. Then run the Docker image. Inside the Docker, run the quick-run script and wait a few seconds. The minimizer started from a much larger program and stripped away unrelated classes and methods, keeping only the essential elements needed to trigger the bug. Each step validates that the error still reproduces. If a removal accidentally marks the bug, it's rolled back. To date, CrossLangFuzzer has found 32 confirmed compiler bugs across 4 projects, 15 in Kotlin, 7 in Scala 3, 4 in Groovy, 2 in Scala 2, and 4 in Java. All bug reports and minimized test cases are available in the companion data repository. Thank you for watching.